Naive Bayes is ready. So now let's move on to decision tree classification, and there you go. So that happens when you have too many sessions opened on Google Colab. I left it on purpose because I'm sure you will also encounter this situation. And what to do in this situation? Well, no worries at all. That's very simple. Since Google Colab actually allows only maximum 5 sessions to run at the same time, well, what we'll just do here is that for decision tree classification and random forest, because here that's the same, well, we'll just close them for now. All right, and we'll reopen them after we get the best accuracy from these 5 models, okay? So we'll get the best from these 5, then we'll run the last 2 ones, decision tree classification and random forest classification, and we'll see which one wins, which one is the big winner, all right? So now all our implementations are ready. So, of course, the next natural step now is to run all these cells to get all the accuracies of these 5 models. All right, so let's start with logistic regression. Are you ready? Let's click runtime and then run all. And all the cells will be running and we shouldn't get any error. Indeed, and we get, wow, we start with a very good accuracy because we get an accuracy close to 95% for logistic regression. All right, and indeed we only have 4 plus 5 equals 9 errors, 9 incorrect predictions. Wow, pretty good. So let's see what we get with the next ones, you know? And it's really reassuring that we get these high accuracies because we are doing predictions for breast cancer. So we really want to, you know, be accurate on predicting if patients have a benign or malignant tumor. Okay, so let's hope that we can do even better than this. All right, so I'm going to scroll back up. Oh no, actually, I'm going to leave that here in case we forget. So 0.947. Now let's move on to K nearest neighbors. Let's click runtime here, then run all. And there we go, my friends. We're about to get the next accuracy, which is exactly the same one. I just checked that, you know, I put the right model here, but we have exactly the same one actually, which, you know, can totally happen because you just have to make 9 incorrect predictions. You know, 2 classification models can make the same number of incorrect predictions, and therefore you will end up with the exact same accuracy. So that's very interesting, actually. This is the first time I observed this. All right, so, well, let's still hope we can beat this with our next classification models. So now with support vector machine, we're going to click runtime, and we're going to click run all to see that next accuracy we're getting. And all right, interesting, this time we get a lower accuracy, but still a very, very good one. And, you know, that makes me very excited to see what kernel SVM is going to do, you know, with a nonlinear kernel. Because indeed here we get 10 incorrect predictions as opposed to 9 incorrect predictions before with logistic regression and K nearest neighbors. But here with SVM, it's still very, very good. We get 94% accuracy. All right, and now let's try kernel SVM. I look forward to seeing what we're going to get. So let's click runtime and let's click run all. And the accuracy is, yes, we beat it, 95%, 95.3%. That's excellent, and that was actually expected. Kernel SVM, you know, is really, really good. You will get good results with this because, you know, we get flexibility on the curve to catch the correct predictions. All right, so very, very good. But we still have 3 other classification models. Let's see what we're going to get with them, starting with Naive Bayes. All right, so let's click runtime and then run all. And the next accuracy is, okay, so like SVM, 10 incorrect predictions resulting in an accuracy of 94%. All right, that's okay. And now, well, we still have 2 more chances. One with decision tree classification and the other one with random forest classification. So now what we're going to do is we're going to click runtime here, then manage sessions. Then we're going to terminate all these sessions here because, you know, we're only allowed to run maximum 5 sessions at the same time. So I terminated all of them. You can close it now, and we still keep the accuracy, so that's totally fine, right? We keep the accuracy everywhere here, so we can totally compare with our last 2. So let's do this. Let's open first, you know, random forest classification because, you know, it gives them in that order. Well, actually, that doesn't really matter here, but anyway, let's open decision tree classification now. All right, and here we go. We have our last 2 models. I can't wait to try them because I can't wait to see who is going to be the big winner and if we can beat even more that best accuracy of 95.3%. All right, so next step is not to click runtime here because remember, we haven't uploaded yet the dataset into the notebook. So no need for refresh here, all good. Upload, then data.csv, open. Then let's do quickly the same for random forest classification. But first, let's not forget to replace this by data.csv. All good. Now random forest classification, little folder here, then upload, then data.csv, open, then OK. And then let's replace this by data.csv. All right, and now, my friends, we're about to reveal the final podium, the 3 best models with the 3 highest accuracies. So let's do this, starting with decision tree classification. So let's click runtime here, run all, and now, there we go. Wow, that's incredible. We actually beat the accuracy. I really didn't expect this. Usually, decision tree classification is not the winner, but here we have a beautiful exception to the rule. Indeed, we get a beautiful accuracy of almost 96%, 95.9.